Yes, today we are going to continue with this C64 replica board, and I'm going to place some chips. But before that, I'm actually going to do some soldering. And as I was browsing through my parts bin, I actually found this. And this is actually something as rare as a new on-shelf, never before used cartridge port for the C64. Not the port, but the shield that stands on top of this. Why this even should be a spare part, I'm not really sure, but I do have changed my part of the cartridge connectors back in the day, and sometimes to remove that it was easier to take off this first, so maybe that's the reason that this could get damaged when you remove them to take out the cartridge port. So I'm going to fit this cartridge port down in this board so that everything will be nice and in ship shape in that regard. I also did not mention when I first mounted this that this one is an ordinary 1.5 amp 12 volt 7812 voltage regulator, and as this does not have this much power draw, it don't get very warm. But this 5 volt regulator that stands here, it has a larger voltage drop, so it has a lower efficiency, and I did replace this with a modern replacement. So inside of this there is a DC to DC switching regulator, and this will deliver about 2 amps in 5 volt. And I do know that these components can be a bit noisy and introduce some switching noise on top of the 5 volt. And that might prove to be a problem, as this internal 5 volt source is for the VIC-2 chip. I'm actually not sure in this construction if it's for the SID chip. So if we do get some noise introduced with this, we either have to mount some capacitors to filter it out, or we need to change this into an ordinary 7805 and add a heatsink for this. Yeah, so that's what I plan to do first now. I'm going to actually mount this, if I can get this to fit. It should be like, yeah, like so. And I will just solder it down a bit. I don't want to twist it, as it will get more difficult to desolder it afterwards. So that's the first thing I will do today. And of course this will be a bit heavy on the temp, because this is the ground plane and this is a large chunk of metal. So we do need to preheat this a bit. And I didn't even clean the legs on this much. I of course should have done that to make it easier on the solder, but as I've said before, this solder is a really good solder with a good flux core in. Yes, like so. One original cartridge port mounted. And then I have to find some chips and populate these sockets. And I've taken and marked these sockets, as some of them stands, these sockets are unmarked really, so you can place them either way, but the normal thing is to have the notch up against the lever here. But on many of these sockets they're stated the other way around, actually on every one of them except this one. So what I've done here, I've just marked this with a blue pen where this should be. And as both the SID and the PLA, they changed place on some motherboards, and I have marked this with SID and PLA so I won't get confused about that. And also my new on-shelf parts, I have not tested many of them, so this will be a bit of trial and error, so maybe this also will be a fault finding expedition. Yes, now I have been digging to my parts bin, and these are my old test C64 room chips. This is my new on-shelf PLA, and here is two new on-shelf 6526, and both these have a date code of 84, so they are probably among the original chips that I had when I did this business back in 1985. And I also have a 6510 that's made in 86, probably from the same area. This is the VIC-2 chip I'm going to use now, at least as the first test. I know this is working, but this is the really old revision 1 kind, so it gives a very poor picture quality. So I might try to take out another and test that instead. And as for the other chips, I do have here some 27 LS258. I have the DRAM chips here. This is probably something I've pulled out of an old expansion card or something, a 373. And I don't have actually a 74 LS139. I do think I have it, but I couldn't find it straight away. So this is a HCT version of the 139. I'm not sure if that is good enough. And I do have a lot of 4066. That's really some CMOS 3-state switches. And here you can see that this has been hiding in foam for a lot of years. And this foam, it actually draws moisture. And you can see that it's corroded here on the downside of the legs, and you can also see some foam that's sticking to these legs. So I might find some other ones of these, but I'm going to clean these ones first and see if they work. This is Toshiba chips. And in the parts list, the boom that I found on the internet, I have not checked actual workings. It stated that the U8, that's a 7406, that's not the LS version or something else, it's just the original TTL chip. So I found one of these. This is an original Texas Instruments chip, 7406. And the 556 oscillator chip. And I have the 2114 memory and the 74 LS08 and the 257. And this should be what I need to complete it. Oh no, I forgot actually two chips. I do have some SID chips that's not in a C64, but they are not new. I actually have bought them. Yeah, this is an ARM SID I'm going to use in this. And this is also a copy of the 8701 clock chip that should stand here. And this is a modern day replacement of this that's actually made of a programmable clock chip. So this is the parts I will be using in this, and I will start with this now. I will do some cleaning of some of the legs and I will start to populate this. Almost every one of these chips has been used before, so they're easy to fit in the sockets. There are some exceptions. Some of the TTL chips has never been used before. And in the SIF sockets, it doesn't matter anyway, because they can take the chips even though the legs have not been straightened at all. It seems like it was only the 4066 chips that was corroded on the pins. And the rest of the chips, they look okay, and some of them is shiny and bright as they was when they was new, so I'm not worried about bad contacts in the sockets. And all the sockets I've used is double swipe sockets. It's not the one with the round holes, but it's good quality sockets that's used. And I should have washed away the cooling silicone on top of the VIC-2 chip. But as I know this was working when I pulled it out, I'm not going to handle it before I've tested it again. And the legs on these 4066 was really corroded. And there also was some residue from the foam. So this was a lot of scraping to get them clean. Here you can see all the dirt that I scraped off the legs. And of course I put in all the chips, but I forgot one rule. I have to measure the output of the voltage regulators that's on board before I actually put the chips in danger, and this is powering the SID chip, the VIC-2 chip, and some of the surrounding chip. And to be more specific, the plus 12 volt is for the SID chip that need this to output audio. The plus 5 volt that comes from this regulator is on the schematic called the CAN 5 volt, and that actually means that this is the voltage that goes inside the metal can on the board. And the metal can is the VIC-2 chip, and on the older board it was more chips, but here it's just the VIC-2 chip that receives this power. As we can see here, both the 12 volt and the 5 volt is okay and well within range. So it's safe to proceed and put in the SID and the VIC chips and go further on with the tests. I just briefly touch the top on every chip to see if they are warm. As the clock is not going, it's just to check for DC shorts in the chip. I was looking over the circuit now and I realized that this one should be closed when it's PAL. So it stands here PAL short. So I have to solder a wire from there to there. Yeah, and now finally it's time to do some real world testing with live devices. I've coupled this to my capturing device, and this is not the best quality. You have to be warned. This is a very old composite video only capture device. But what? It's actually working on the first try, not even a small glitch. The video quality is kind of poor, but that might be due to the capturing device. Other sources of noise in the video signal can be the RF modulator replacement, that this is the R1 VIC-2 chip, and that we have the 7805 replacement chip that can make some switching noise. But now let's connect the test harness to make a full complete diagnostic test with the diagnostic cartridge. And this is actually a harness I built myself several years ago. I did have an original harness back in the day, but I gave it away or it's lost in the mist of time. But this one is fully working. It might not look the part, but I can assure you it's working quite fine. I do have several versions of the diagnostic cartridge, among others an original one that I had since back in the day, but I like this newer version that also tells me the version of the kernel ROM instead of just displaying an error if there are some changes in the kernel. And this is also the one with a dead test cartridge on the other end, just flip it. As you can see, I have to remove the plastic dot on the level on the 6526 that's pointing against the user port to make the adapter fit. When it comes to the audio test, we have to remember that this is an ARM SID, and the ARM SID should recognize itself as the 6581 due to the 12 volt power supply. Otherwise, I have not done no settings on that. Yeah, but this seems to be working just fine. We have to analyze it a bit better, but so far it's okay. This is one of my original test keyboard, but as you can see, I have pulled the shift lock from it, and it's also missing a key. That's probably because of bad storage. The shift lock key I probably took to another C64 back in the day, because I don't seem to remember that that was an original spare part, so probably I helped someone out with just swapping out my key and that's it. That's probably also the reason why I did not return this keyboard to Commodore, as was the custom when I had replacement keyboards. As you can see, this keyboard is in dire need of some servicing. It's almost none of the keys are working, and those who are working, you have to push real hard and long to get a response. But I do think we have proven that this is a keyboard fault. It's not the fault of the C64, so I don't think I will do any more testing here, but this keyboard is definitely going into the need repair pile. And this keyboard has never been serviced before. I can see that because the screws beneath the tape here has not been removed and the tape is intact over all the screws. So that's probably a good sign that this keyboard has never been opened before. Yes, so far in this build I can see that it has been a huge disappointment for me that everything works from the get-go. I do appreciate the good fault-finding session, and that I could not get from this build. And I think it's a miracle that every one of these ships that has been laying for, since the mid-80s, that they're still working out of the box. It's nothing short of a miracle. And I also been digging some deeper, and I found this. This is C64C keyboard, and it's the newer versions with the print only on the top of the keys. And this is actually a keyboard I found on the local dumps a couple of years back. I forgot that I had it, and I have not tested it, and it's also in a kind of a rough shape. It's kind of dirty and it's yellowed a bit, and but it doesn't look that it has been opened, and I'm going to test that. And to complete the build we do need a case, even though I'm going to use this motherboard, the C64 Sixtyclone, as a fault finding device and mainly to test ships when I do repairs on other Commodore 64s. It do need a case, and for that I'm going to use this. This is one of the cases that's been molded on the original Commodore molds. Back in the day Commodore had several molds for the C64C, as you can see, some with the screw fittings, some with the clamps and so on. But this is the first batch of these cases that was made. It's not the batch that's currently sold out of Germany. This was made before the forms was sent to individual computers in Germany. And this I actually bought out of eBay a couple of years back, and I originally planned it to use on my Ultimate C64 mainboard. But instead I'm going to use it now for this build, and in some cases it would have been better to use an old bread bin case, because the bread bin do have some advances when you do this kind of fault finding. You do have that the keyboard is smaller, so when you want to put the keyboard besides your build or your fault fighting device, it takes less space. And it's also that the keyboard on this sits on top of the main board and is kind of not attached to the top of the case. But I will try out this and see how it works. So that's what I'm going to start with now. I'm going to fit this in the case. And I also want to address one other issue before I get so far as that. I've discovered that the cartridge port on this Sixtyclone board, and I don't know if that's something that's within specification or not, but if I try to take this board and put in my original final cartridge tray from back in the day, I actually find that the PCB here is actually wider than the cartridge connector. So I do have to take a file and I do have to make it a bit narrower over the top. Otherwise, the plastic on this is too wide to plug in cartridges with a plastic housing. But these cartridges that's just PCBs, they work just fine, like so. So that's the issues I will be addressing now. Here I'm just using an ordinary metal file, and it fits rather nice into this groove. So I'm just struggling a bit because this file is very sharp and the glass fiber is kind of hard. So it's just to get this going. It's not much that should be taken away. It's about 1 millimeter on one side and a bit less on the other side. This is fiberglass dust, so it's not wise to get this into anything. At least it's better to keep it contained. So I'm going to dust this off in the dustbin. Yeah, I'm going to check if this is enough. Yeah, and it is, at least for this cartridge, and that's good. So now we are going to see if we can make this fit inside this case. This is the motherboard that was fitted in the first version of the C64 case. So there really should be no big problems with this. You can check the height of the standoffs, and that looks okay. And I do have maybe an issue with this. This power connector is not going as far out as it should, but I do think that this will fit quite nicely. And to get support for the keyboard on top of this, we do have these standoffs, and this is something I 3D printed some years ago. I got this case. Yes, something like so. I do have some not so original plastic screw here that I will try to use. I think the secret here is to use as short screws that you can get away with, so we're not expanding the threads of the screws. And then I missed this screw, but that's not a big problem so far. And I will need to make another power lead. This power lead here is actually for my blue. I have one of these for every of my C64 transformers. This is the blue one. I have one red and one green. So I have to make a new LED that's more like the original. The power is working okay, and the joystick ports are fitting nicely. So, what about the keyboard? The keyboard should stay like so, and I do think it just should stand like so. I do have some place for screw here and here, but I don't think I will use those. And this is the previously untested keyboard. Maybe there was some issues with it, but I rather think that they just tossed away the parts after they took apart the C64. So the top lid, it's of course without badges and everything because this never been used before. I had this lying in a box for years now. But this fits okay. So I do need quite the long power LED leads, so that I will fix. Otherwise this seems to fit okay. I can just test this now to see how this works. And also on my blue LED power supply and my blue top power supply, I have a blue power connector so that they won't get mixed up if I have more than one 64 on the bench. I actually do have had some accidents back in the day with napping out the power on the wrong C64s. Yes, let's try to turn it on. I actually have to turn on the power supply first, I forgot. Yes, and that works rather nice. And let's test the keyboard. I think we can say that this works rather nice and quite in the good shape. I will just test a cartridge now with the cartridge port fixed, like so. Yes, and it boots straight into the menu of the final cartridge tree. But I just need to make a good longer power LED for this, so that I will start with now. I have to find a LED that actually fits in this hole. This one is about right, but it's a little too thick this way. Yeah, it's all the same. The different kinds, you can see that the legs and small difference in the color, but you actually have the same depth and width, and these are much more square, and this is a triangle shape. It's also possible to do 2-3 millimeters and just glue them in there. I might have to consider that option, or I can take one of these and just file it down a bit. It's just plastic after all. These yellow and orange ones would have been rather nice because they are very bright. But it doesn't look like we have any in the right shape. Red ones. And here I actually have one that's smaller than this. It might fit. Another one. Do they fit? Yes. So I will try this one and see if they are good enough. This is probably 30 years old, so I'm not sure if they actually are working. And if they are working, how bright they will be. I will test both of these for brightness and check. And a red LED, it should have about 1.7 volts, 1.5 volts, something like that. So I will put on my power supply, I will give it 2 volts, and I will put a current limitation on that and see what happens. I will actually dampen the light a bit so it's possible to see if this lights up. Yeah, and this is actually how much this lights up with 10 milliamps about in current. But the light is actually quite good in these LEDs, but now we will try to test both of them at once to see which of them is brightest, and we are going to choose the one with the brightest light. And we can see that the bottom one here is less bright and the top one was brightest, so that we will use. Yeah, I will take this lead that's quite long. It will reach more than to the end of the case, but then I have some lee room if I can make it a bit shorter, maybe, like so. Yeah, I just prepare the leads for soldering and take some heat shrink tube to isolate the legs on the diode and also to keep the cable from unraveling after we have soldered it. I cut both the legs of the diode quite short so that they won't take much space beneath the cover, and it's also much easier to keep them from being tangled in something when this will be taken on and off all the time. Yeah, here I used side of the soldering iron to shrink the heat tube, and that's a good technique. It won't overheat things and you don't use open flame. Yes, and then it's just to mount it in the lid and we should be ready to go. Yeah, it lights up, but it's not the brightest among lights. I do think I will do a slight mod on this to increase the current through this LED a little bit. Of course, the original C64 was actually quite the warm beast, so it was no reason to run more current than necessary through the LED, but I have actually made the power supply more efficient both in the wall wart and in the C64 itself, so there is no reason not to increase the power a little bit. And the current that runs through this now is just a little over 8 milliamps, so I want to double that. The simplest way for me to do it is just to add another 390 ohm resistor in parallel over the R39 that's there today, and that we actually did, and the light was much more bright afterwards. That's it for the second episode in my series of building this Sixtyclone Commodore 64, and we have actually made this into a complete Commodore 64 in this episode, and everything is working quite perfectly. We have not tried it to a serial device, but we have tried it via the test harness and the test cartridge, and it works okay. So what will be next? I will try to use my screen capturing device to actually see if there is something wrong with that, or there are some noise in my Sixtyclone that's caused the video output to vibrate. And my video output device is this quite old thing from Koenig, and StarTech and others have the exact same device. It's a simple USB 2 device with video inputs like this. Yeah, it's working quite nice. There are some troubles with Windows drivers and so on, so there are some lag in the screen and it's not very fast. But to record things that doesn't have very much action in it, it's quite okay. But this is it for this episode, and in my next episode in this series I will actually start to work on some Commodore 64 stuff, and I do have some old boards that I want to look into first. So please hit like and subscribe so you will be notified when we post the next installment. So then you will see some actually Commodore 64 repairs, not this big disappointment where my build here actually worked on the first try. So thanks for watching. Hope to see you in my next episode.